Okay, so today we would like to move to the chapter 3, and the topic is related to the fluid statics. Okay, and then we will have the quiz today. So the key knowledge for this chapter, we are focusing on hydrostatics. Okay, so it indicates there is no velocity gradient. As I teach before, the velocity gradient is corresponding to viscosity equation, right? And based on its viscosity equation, we will have the shear stress. So if we have the shear stress, that means there is somehow velocity gradient there. Okay? But in this chapter, we neglect the viscosity effect. So we don't have the velocity gradient, so there is no shear stress. So for this chapter, we only focus on the normal stress. And as I mentioned, the normal stress is related to the pressure. And the pressure is caused by the weight of the fluid current. Okay? So that's some sentence showing here related to the static. That means if the particle, we call that the particle is status. That means the particle didn't move. Or the particle moves with a constant velocity. Okay? So the outcomes showing here, the first one, we would like to introduce the pressures and some important unit that I show: the gauge, absolute, and the vacuum. So I will introduce what are the meanings of the gauge, absolute, and the vacuums. And then some ideas we can apply the hydraulic machines to solve some mechanics problems. And then most important equations I will teach here is hydrostatic equations. Okay, so that's very important for these equations. And then how can we measure the pressures? So these chapters just introduce the tool and the methods to measure environment pressures. Okay, and then since we have the pressure, so we can convert the pressure to the force. If we have the area, so we can convert the pressure to the force, and we call that the pressure force. Okay, and we have the force. So how about our target? So there are two targets in these chapters. The one target is the plate. As you can see, there are two plate structures. One plate is planar plate. Another plate are the curvature plate. And then you see actually the difference force above the plate, right? So you see the red angle, the black angle showing here, the lengths are different, and the increase as the depth increase. And you see on the right hand side, the force distribution are totally different if you consider the different shape of the plate and the plate beneath the water or liquid somehow. And then you can see the force distribution are totally different. So how can we determine the force distribution based on different cases? Okay, so it's very important. And the final one is the buoyant problems, as we have the boat on the sea waters, and we can control the boat will rotate, and the reason why the boat can floating on the water surface. So we need to discuss the conditions. If the boat rotate over and will merge into the water, okay? So this is our outcomes for this the chapters. Then so for each chapters, if we introduce the new parameters, we will introduce the unit of the parameter first. So every student, we know that the pressures, the unit for the pressure is the force per acting area. So in the in the data unit, we will say that the Newton per meter square, right? And we call that the unit is equal to the par. So this is the PA. It is the PA, right? The unit here is the par. Okay, and but there are show some other units for the pressure. As we can see the PSI, in here. We have the PSI, right? And then we have the PSF. So what is the PSI? So the PSI is the bound force per inch square. And then we call that is the unit is the PSI. So the similar ways, what is the PSF? So the PSF is the bound force and the per meter square. And so we call that is a PSF. And here the slide already tell you the unit difference, right? So you can try to convert. You can convert the unit by yourself. As I mentioned, if the one part, so it's equal to how many PSI and how many PSF, right? So we need to convert the unit by ourselves. So here I know that the one pound force is equal to the 1 pound mass, and then multiply the 1 G, right? And the 1 G is 9.81 meter per second square. Okay, so we can convert a 1 pound mass to the kilogram. And as I mentioned in our previous class, we know the 1 pound mass is equal to the 0.454 kilogram. And then you multiply the 9.1 meter second square. So you know that the 1 pound force is equal to how many newtons? Okay, so you compute by your calculator is around the 4.45 Newton. Okay, so as I mentioned, so right now we can convert the Newton to the bound force, right? So we know that the 1 part is 1 Newton per meter square. And it's equal to how many bound force we have. So we can convert, divided the 1 divided the 4.45. Right now the unit will convert to the bound force, right? The 1 Newton divided the 4.45 will convert to the 1 pound force. And the bottom is the meter square. And then we know that the 1 FT is equal to 0.305 0.548 meter, and 1 inch is equal to 2.54 centimeter, right? So you can convert the unit by yourself. And in here, if we multiply the 0.3048 square, and the unit will convert to the ft square over 1. So in that case, I can convert the 1 part equal to how many PSF we have. Okay, because the 1 ft is equal to 0.3048. So we can convert the meter square to the ft square, divided the 0.3048 meter. Okay, so because we divided here, so it's equal to multiply on the top. Okay, so you can convert. You know that's how many PSI you have. Okay, so this is a very small number, so you can compute by yourself. And okay, it's equal to the 0.02 around the 1 PSF. Okay, so I just show one example. If you know the unit, so you can convert by yourself. And some important numbers you can keep in mind. And if you meet the problem, so you can convert very easy based on the ideas, the relationship between two different units. Okay, so, and we know that if we would like to understand how the pressure here, so we can put some liquid, and we see the different liquid will have a different height. As the example showing here, we know that maybe we put the water in the tube, and we see there is a rising height, right? It's a rising height. Its delta H is the 8 inch. And then you can compute the 8 inch is equal to how many pressure we have. Okay, if I tell you the hydrostatic equation, we know that the pressure is equal to the gamma. Gamma is specific weight, right? And multiply the delta H. This is based on the hydrostatic equation I will teach in the following class. But here, you can check the dimensional. You see the gamma, what is the gamma? The gamma dimensional is the Newton per meter cubic, right? And the delta H is the height. It's a liquid height, like the delta H showing here. So the unit is the meter. If you multiply two parameters together, we'll have the pressure unit. The pressure unit is Newton per meter square, right? So the unit is consistent. So based on this equation, I can calculate how the pressure inside here, based on the delta H I have. So the gamma weight, I know that the gamma here is the water, for the water. So we know the gamma is 9810 Newton per meter cubic. And the delta H is 8 inch. And as I showing here, 1 inch is equal to 2.54. So it's equal to 0.0254 meter, right? So you can put here, there is the 8 inch. So here is multiply the 8 and 0.0254 meter. And you can use your calculator to compute how large of the pressure. So my computer showing here the answer is around the 1.99 K par. Okay, so you can double check the answer showing here. Okay, so in practical, you can put some liquid in the tube, and you can see a rising height of the tube. And you can base on the rising height to measure how the pressure inside here. Okay, but I didn't teach, so you cannot fully understand why we can compute the pressure based on this formula. So in the following class, I will teach you the reason why. And then, so if I say the 1 atm, what is the 1 atm? The 1 atm is relatively to the pressure at the sea level. Okay, so and as a standard condition, the standard condition like here, the temperature around the 15 or 20 degree is a standard. Okay, so the famous unit 1 atm. So we know the 1 atm is equal to 1.013 kilopar. Okay, so you can in the following slide I will show the number not only for the par but also for the PSI and the PSF. Okay, and then this slide just show the common sense. Usually we will have some lower pressure area, like the bottom figure showing here. We may have the higher pressure and we may have the lower pressure. Usually we see the lower pressure that indicate the bad weather. If we see the higher pressures, and that means this is a good weather. And the sentence already provided the reason why. So I really like the windy. You see, this is a windy. Windy is very good. As I can show in here. Maybe I have the windy, right? And I just plot the windy. And because right now I don't have the Wi-Fi. If you have the Wi-Fi, so you can show out the current weather on the Taiwan, and you can see somewhere it's higher pressure. In case you can check from your cell phone. Right now it's a good weather, so that means there are some higher temperatures around the Taiwan island. Okay, because right now we have a good weather at this time. Okay, so usually I go a field trip and I can check the weather by myself, and I can decide is go there or not. If the bad weather, I may go other side, right? Okay, so just the slide just summarize some important ideas in our life. So totally we have the three methods, and how the three methods showing here is you can double check by yourself. Aside the method ones, you can Google the digital touch online calculators, and then you see you can put the how altitude. The altitude indicates the elevations relative to the sea level. So you just key the altitude and right now the temperature, and the calculator will tell you how large pressure in there. How large pressure in layers, and how about the air densities and the sound speed and the dynamic viscosity at these conditions. So the method one is quite simple if you have a cell phone and you can check by yourself. But the key knowledge is altitude. If you don't know the location here, the altitude, how large it is, you cannot use this calculator, right? Because most important information is the altitude. The temperature is quite simple. You can use some temperature meters, and you actually know the temperature at your locations. And the method two, you don't have altitude, how can you calculate the pressure? Okay, so it's quite simple. You can have some assumptions. Okay, because you don't have elevations, so you just assumption is you assume your pressure is at the sea level and equal to 1 atm, and is equal to 101.3 kilopart, and some numbers very important showing here for the PSI and the PSF. 1 atm is equal to 14.70 psi and 2116 PSF. Okay, and as I mentioned, the pressure can measure from the fluid height. So it's 1 atm equal to the 760 millimeter mercury height. So if you change the mercury to the water, you will have the around the 10 meters, and the 10 meters equal to 33.9 ft. Okay, so the different liquid you will have a different height. Okay, so and then the final method, if you have the meter, so you can base on the meter to measure the pressure on site. Okay, so totally we will only have the 3 methods to measure the pressure for the ATM or for at your environment. Okay, so today we may stop here.